Systems of equations can be either solved by substitution or by addition subtraction. The first one here we're going to solve by substitution. So we're going to look for a variable to isolate, and then we're going to substitute that variable into the other expression. So in this case here, looking at the coefficients, it looks like it'll be easy to solve for x without a fraction. Now, a fraction, it doesn't mean that you can't do it, it just makes it a little bit more difficult. So we want to maybe try to avoid the fraction values here. So I'm going to end up with solving for x. So I'm going to get 8y plus 18 equals 2x. Solving for x, I get x equals 4y plus 9. So I'm going to take equation 2. And I have to remember that I can't substitute back into equation 2. I have to substitute into equation 1. So as I substitute for y in equation 1, I end up with 3x. So I'm going to substitute for x. So I'm going to end up with 3 times 4y plus 9 minus 2y plus 17, and that's equal to 0. So replacing that x with an equivalent 4y plus 9. Okay, I'm going to go ahead and solve for the y variable. So multiplying out these brackets, I end up combining my like terms. So I end up with 10y plus 44 equals 0. Solving for y, I get 10y equals negative 44. Dividing by 10, I get negative 4.4 for y. Plugging that back into here to solve for x. Okay, so I substitute that in, negative 4.4, and I end up with an x value of, looks like negative 17.6 plus 9 is going to be negative 8.6. So x is equal to negative 8.6, y is equal to negative 4.4. And we can always check these by graphing these on our graphing tool. We can also solve by addition subtraction. So for addition subtraction, we want to try to equate the coefficients, and we can eliminate one of the variables by addition or subtraction. So I'm going to take equation 1. And I'm going to make the x variables the same. So we're going to eliminate the x variable. So I'm going to take equation 1 and multiply that by 3. So I end up with 6x minus 54y minus 6 equals 0. Make sure that we're multiplying every term in that expression. Okay, going to do the same for equation 2. I'm going to take equation 2 and multiply it by 2 to equate the coefficient on x. So I end up with 6x plus 10y minus 70 equals 0. Okay, so I can now combine these two equations. I'm going to subtract and eliminate my x variable. So I end up with negative 64y plus 64 equals 0. Solving for y, I get y equals 1. Okay, and then to solve for x, I can substitute into either equation. I'm going to substitute into equation 2. So in equation 2, I will substitute for y and solve for x. So I end up with 5 times y is equal to 1. Okay, so y is equal to 1. Solve this equation for x. I end up with 3x plus 5 minus 35 equals 0. So 3x minus 30 equals 0. So x is equal to 10. So our solution for this system is x equals 10, y equals 1.